So once again, this is not detailed overview about the Terraform and OCI. This is just only the brief introduction and brief overview about the Terraform and the Oracle Cloud Interface. Sorry, infrastructure. So first of all, infrastructure as a code. So basically, till now we are creating infrastructure by console, right? So we are using console and we are doing multiple clicks and adding proper values and creating the infrastructure. Now, after this, after installing Terraform and configuring Terraform, we will write an infrastructure in the form of code. So whatever the VCN we require, we will write a code over there, and Terraform will create it for us. Whatever the subnet, whatever the PCN, whatever the subnet, whatever the compute instance, whatever the load balance, any infrastructure can be coded and executed, created by Terraform. So infrastructure as a code is the process of managing infrastructure in a configuration file or files. So there could be a single file or there could be a multiple files. And it allows operator basically operator means us, it allows us to use configuration language to write configuration file. So basically in Terraform we will write whatever the infrastructure we require in the form of the configuration file, and contains definitions of our desired resource inside a file. So whatever the resource we desire, we will write it up in the configuration file. And it supports almost any provider: AWS, GCP, Azure, even Docker and OCI, Alibaba. So each and every provider is supported. So learning Terraform is very good and very important for us. And basically it automates the creation of those resources at the time of apply. So whenever we execute Terraform apply, then the infrastructure get created. So we have a Terraform for that, for the infrastructure as a code. So Terraform is the infrastructure as a code offering from HashiCorp. So HashiCorp is the company which has developed Terraform, and it is an automation tool for building, changing, and versioning infrastructure safely and efficiently. Safely because whatever the written in the configuration file, it get created and it won't create it outside of the configuration. So every time you execute a Terraform apply, it will create exactly same amount of resources that you have written in the configuration file, and efficiently because you do not have to click, you do not have to go to browser and all this stuff. You can do it efficiently from the Terraform command. And there are configuration files described to Terraform the components needed to run in a single application. So whichever the configuration we have defined in a single Terraform configuration, it get, excuse me, sorry, it get created at a single shot. So after that, the infrastructure team. So basically, infrastructure team means we use configuration language called a HashiCorp configuration language HCL. So basically, to write a Terraform configuration file, we use HCL. And the basic workflow of Terraform is we will define the scope. So basically, scope means we will figure out whatever the resources that is required for us. So we will figure out, list them all, and after that we will write the configuration files. We will basically write whatever the configuration files, whatever the shape of, let's say if we require a compute instance, then we will define, we will write which, what is the name of the compute instance, what is the shape of the compute instance, what is the uh, OCID of the image that is being used to install the operating system, and what is the size of the boot volume. Everything is defined in the configuration file. And after writing all of them, we will do a initialize. Basically Terraform initialize means we will download the all required plugins that is being used by the Terraform. So basically if we are going to deploy Terraform, we are going to deploy the infrastructure using Terraform for OCI, then we need to download OCI plugin during the initialization phase. And after that, it will we will use a plan and apply. Basically, plan means it will figure out all the resources that is being created, and it will display in the format of the some sort of the format. So it will display whatever the computing set, whatever the PC, and whatever the software that is being created. And once we are agree with it, then we can apply with the command Terraform apply. So this is the basic workflow of the Terraform. And installation is pretty easy. Just you can install Terraform for any OS. The best part is any OS. Go, you can install it on a Mac, FreeBSD, Linux, OpenBSD, Solaris, and even Windows. And there you can also install in a 32-bit and 64-bit of Windows. And we can select the operating system and architecture, whichever the operating system we have and whichever the architecture we have. And after that, we will extract the compressed file. So once the extraction is done, we will add the location of the path environment variable. So basically, once the extraction is done, we will add the path environment variables, and we will configure CLI version of a cloud provider. So basically, if we are going to use Terraform for OCI, then we need to download and configure OCI CLI. So basically, OCI CLI version of the OCI, command line version of the OCI, and we will do it on the hands-on lab itself. So basically, there is a configuration. Configuration is the set of a file used to describe infrastructure in a Terraform, and the Terraform is a declarative model for defining infrastructure. So in case the the meaning of the declarative model means whatever you require, you can just declare on it. So it doesn't matter you declare it on the top or on the bottom. You just need to declare it, and the order actually do not matter at all. In most of the programming language, that is being procedural programming language, if you define something in the top, get execute at first, and the something defined at the bottom get execute at the end. So but in the case of the in the case of the Terraform, it doesn't matter either you define it on the top or bottom. Let's take an example. You need to create VCN first, then only you can create a subnets inside it, right? So it doesn't matter if you define the subnet at the top and the VCN at the end, or VCN at the top and subnet at the end. So it doesn't matter. The order does not matter at all. And configuration files are made of the resource with the settings and values. So we will define the resource, whatever the resource we need, and we will set the values for them. And configuration files can be either of the two formats. So you can write it on the HCL, or JSON is also supported. So in case of a HCL, then HCL format files have a .tf extension, and for the JSON we have a tf.json as an extension. And the configuration can be composed of both tf and the tf.json extension. So you can mix both of the extension also. So this is the example of the configuration files. In this case, that all the files that ends with the tf are the configuration file, Terraform configuration file. We have a vcn.tf for the, I have defined the vcn related values, vcn related resources over there. We have a variables.tf, I have defined variables over here. Providers.tf, I have defined providers over here, and the output.tf, where I have defined the output variable. And we have a TF state for the state files, and the plan for the planned output file. We will discuss it later. Now we have a provider block. So basically, provider block define the named provider. So basically you can use the Terraform for anything, right? Any cloud provider, right? So it could be AWS, OCI, Azure, Alibaba, Docker, or whatever thing. So it is a provider block which defines which provider we are going to use. Let's say in the example, we have provider OCI. This means all the things, all the list attributes and value defined with this block is for the OCI, and we are going to use OCI for this Terraform deployment. So a provider, basically a provider is a plugin that the Terraform used to translate the API interaction with the service. So the provider means the plugin that is being used. Terraform can interact with any API. You can represent almost any infrastructure type, either it's a AWS, OCI, Azure, or anything else. And the best part is multiple provider block can exist if the Terraform configuration management resource from different provider. Let's say we can have a provider for the OCI and provider for the AWS on the same configuration file. So we can define this one compute instance in the OCI and another one compute instance in the AWS with the same configuration file at the same time. And here is the example of the provider block. So if I open the cat provider, providers.tf file, then we have provider OCI. Here is the provider name, and I have defined the attributes and values: tendency OCID, user OCID, fingerprint that is being used, private key path, and region that is being used for the provider. Now we have a resource block. So everything we define is a resource. BCN is a resource, compute instance is a resource, load balancer is resource. So everything we define is a resource. The resource block defines a piece of infrastructure. Basically, it's an infrastructure, and the resource might be physical components such as a compute instance or the logical resource such as an application. We even defined a resource for the application also. The resource block has a toString before the block of code. So basically, this is the block of code and this is the resource keyword. So after resource, we will have a two keywords that defines the resource type and the resource name. In this case, we are defining this as a resource block, resource OCI core VCN. Everything starts with the OCI core, and OCI core VCN means we are defining resource for VCN, and the name of the VCN is load balancer VCN. So this way we will define the resource block, and everything within the curly bracket is the list and attributes for the VCN. Okay, here is an example for the example from the VCN.tf. So I am defining VCN with the name of the Terraform VCN. Then CIDR block I am going to use is 10.0.0.0/16. DNS label I am going to use is a Terraform VCN. Compartment I am going to use is part.compartment.ocid. Basically, all the values that is defined with the part dot means it's defined in the variable, and the display name is the Terraform VCN. And this is the resource block for VCN with the name Terraform VCN. Next, we have a data block. So data block requests the Terraform read from the given data source. Basically, it reads the values from the existing resource. Let's take an example. Let's say I have to create a compute instance using a VCN and the public subnet that is already defined by another configuration file, or that is already exists. Then I need to use a data block to read the values, to read the OCID values from the existing compartment. So in that case, I'm not going to define the resource block for the VCN because it is already created, right? I will just use a data block and read all the required values. Here is the example for the example of the data block where I have read the values of availability domain and the VCN that is being already created. So data blocks, data source allows data to be fetched or computed for the use, and the use of data source allow a Terraform configuration to make use of information defined outside of a Terraform. So that could be the resource that is defined by someone using the console or defined by another separate Terraform configuration. Let's say I have a colleague who have created a VCN and subnet using a different configuration file, different Terraform configuration, and I need to create a compute instance. Then to use the subnet and the VCN that he has created, I need to use a data block. So this is the example where we begin with the data keyword and the name of the resource type, and then we will give the name of the data block. So in this case, data OCI identity availability domain, this is the keyword that defines I am going to use availability domain for this data block, and the name of this availability domain is AD. And the AD number I'm interested, availability domain number I'm interested is a 1. So it basically refer to first availability domain, and it's all details. And in the same way, I'm using data block for the BCN data OCI core underscore BCN, and the name I have given is a Terraform BCN. Compartment ID is compartment that I am getting it from the variable value, and the display name I am interested in. The BCN that I am interested on has display name Terraform BCN. So one of the colleague who had defined the BCN has display name Terraform BCN, and I'm going to use it. So finally, we have an output block. So output block basically returns the values and the label immediately. There is an example. The label immediately after the output keyword is the name. So in this case, output BCN ID. So BCN ID is the name, and the value it get printed is the OCI and so core and the BCN, the Terraform BCN ID. So basically, it will print OCID of the BCN with the name Terraform BCN. And the value argument takes an expression whose result is to be returned. Basically, it is used in the case when we need to have a return values. Now we have a provisional block. So the one we discussed earlier is a provider block, and this is provisional block. So provisional block defines the block of code that need to be executed after the resource is being provisioned. And there are two types of provisioner, that is local exec and the remote exec. So provisioner can be used to model specific action on the local machine or on the remote machine, prepare server or other infrastructure objects for service. So basically provide provisional prepares server. So basically it makes a server ready to operate. Now, in case of the local exec executes, invokes a local executable after the resource is created. So basically, local exec is the list of command. When we define the list of commands with a local exec, it get executed on the machine where you have initiated Terraform apply. So basically, it executes on your, let's say if you have installed Terraform on your laptop, then the block of code defined on the local exec get executed on your machine. So the use case of this local exec is that if you configure a compute instance and at the end you want to save the IP address of compute instance in your laptop for another purpose, then you can use a local exec block. You can save an IP address of the compute instance, you can save the password of the compute instance, you can mail it to the person, you can do a lot of things. And there is another block of provisional code, that is remote exec. Remote exec invokes a script on the remote source after it is created. So basically it get executed on the compute instance that you have created. Inside a compute instance you have created. So it doesn't create on your laptop. It doesn't execute on a laptop. So it is used to run a configuration management tool. Basically, let's say I have to prepare a web server, then what I can do is I can add a block of code that need to be executed after the provisioning. Post provisioning script can be attached to the remote exec, so that whenever the provision get completed, it connect to the compute instance that is being created, and after that it will execute all the required steps that I have defined. And it is used to run a configuration management tool, likewise installing software inside the compute instance that is being created with the Terraform code. So the use case or the example you can use is that you can install Apache, configure firewall and enable firewall once the compute instance is ready. So basically in our previous hands-on lab, we have executed yum install manually, right? So this can be attached to the remote exec itself so that it get executed at the end of provisioning. Next, we have an input variable. So we can define a variables in the Terraform. There are multiple ways to define a variables. We can define it with the configuration file. in the first example, variable regions default equals to US as one. So variable is a region and the value is a US as one. And we can use a Terraform apply hyphen var as an option. So in this case, Terraform apply hyphen var, I use the option var equals to region equals to US as one. So in this case, region is my variable and US as one is my value. And even in this case, if we define the variables, then the variable, we call the variable with the keyword var dot variable name. So in this example, we are defining provider block where we are using OCI as a provider, and the user underscore OCID is var dot user OCID. So basically, the variable name user underscore OCID has a value for my variable user, my setting user underscore OCID. And the next form we can use is a terraform.tf var. So whatever we have defined in the terraform.tf var is considered as a variable and values. So in this case, we can use a region equals to US as one. So the region is a variable and the name of the value of the region is US as one. And in the same way, we can use a var hyphen file option to define the variable files. Excuse me. So in this case, the var hyphen file, my file one has a variables defined within it. So we can have a multiple var file option, and we can define the multiple variable file also. And the most popular method is the using environment variables. We will use environment variables, and all of the environment variable will be need to be prefixed with a tf underscore var underscore value. So in case of the region, if I need to define a variable and value for the region, we need to export tf underscore var underscore all in the caps, then the name of a variable, here region is the variable, and us as one hyphen one is a value. Let me get the pointer. So in this case, this is the value and this is the variable, and the variable need to be preponed, means need to be prefixed with the tf underscore var underscore. So this is the mandatory one. And the last option is the interactive prompt. Let's say you use the variable value, but you have not defined it anywhere, and you execute Terraform apply this command, Terraform apply command, then it will prompt the value for it. So let's say I have used the region variable var dot region in my configuration code, and I haven't defined the variable value for the region. So whenever I execute Terraform apply, it prompts for the value. So it asks for the var dot region interrupt value for. So we have a state file. So whenever we apply the Terraform configuration, the Terraform, all the resource that is being defined in the Terraform configuration file get created, right? So once it is created, it maintains all the resource that is being created in the state file. So state file is the file where the existing resources that is being created are listed. So state file stores state about your managed infrastructure and configuration. It is used by Terraform to map the real world scenario, real world resource to your configuration. So whenever you change anything in a configuration, then it will compare with the state file, and it will list out whatever the change that is being reflected by your new configuration. So we can define the state file locally or the remote location. So we can store locally because it can be stored on the local region, local site also, and in the remote site. Let's say if you have a 10 developers working on the same Terraform project, and they all have the they all have the configuration file at their machine itself. So in that case, if you maintain the state file locally, then there is a chances that the state file get mismatched, and one have different state file than the another one, right? So in that case, we can use a remote state file and store it in the object storage or S3 bucket of the AWS. So in this case, remote state file, we are defining remote state file and the data Terraform remote state, and this is the name of the project. It could be anything. Backend equals to HTTP and the config address equals to this. So the main advantage of using remote state file is it can be used by the multiple developers, and there is only one single state file that is the truth for every developers. These are the basic Terraform commands we are going to use. Terraform init to download plugin, Terraform validate to check the syntax of the configuration file we have right. Then we have a Terraform plan. Optionally, we can define the output file also. So basically, Terraform plan will list out all the plans, all the infrastructure that is all the resource that is being created, and we have a privilege to save the plan to some plan file with the -o option O and the plan file name, and we can execute. After that, we will execute Terraform apply, and Terraform apply we have an option to add up Terraform plan file name. So basically, the plan file that is being saved at the stage of the Terraform plan can be reused in the case of Terraform apply. And after that, we have a Terraform show that will list out all the infrastructure that has been created. And final command is the Terraform destroy. These are the basic commands that is being used. So at the end of Terraform destroy, whenever we use Terraform destroy, all the resource that is being created get destroyed. Yeah, this is some outputs, Terraform init, and it will basically, if you check, then you will notice that it will download the Terraform. It will download the plugin, downloading plugin for the provider OCI and HashiCorp OCI, and the version is the 3.79. And the second command we have is a Terraform validate. It will check for the syntax of the Terraform configuration file, and if you have everything perfect, then you will return with the value you will get return success. And third command we have is a Terraform plan. So in case of Terraform plan, we have an option, we have a privilege to save the plan for later use. So Terraform plan, either you can use a Terraform plan or you can use a Terraform plan option -out. This will returns the all output. It will write all the output to the pcin.plan file. Sorry, it's a PNC plan. So this is the output you will get with the Terraform plan. So this is how the Terraform output will be displayed. Terraform plan output will be displayed. And after that, we have a Terraform apply PNC.plan. So if you apply it, then the resource whatever defined in the plan file get created. So in the case you use a plan file for apply, you will not be list out with all the plans again, and you are not prompt to confirm the apply. So if you just execute Terraform apply only, then it will list out all the resources that is going to be created once again, and it will prompt for you to confirm the changes. So when you type Terraform show, it will display something like this. You have a resource OCI PCN's detail and subnet. All these things are displayed with the Terraform. And finally, we have a Terraform destroy command, where all the list that is going to be destroyed are displayed, and you are prompt to confirm the destroy. So you have to, at the end you have to type yes to destroy the resource that is being created with the Terraform configuration file. And we have an option to use auto approve. So using auto approve option, we can destroy the Terraform without prompt. So Terraform resource can be destroyed without prompt using auto approve. So in this demo, we are doing hands-on lab on installing Terraform, and once installation is complete, we will do demo. And demo, we will create one BCN that is with the name Terraform BCN that has a CIDR block 10.0.0./16. And inside this BCN, we will create two subnets. One is a public subnet with the IP address 10. With the CIDR 10.0.0/24, and we will create another subnet, private subnet, with the CIDR 10.0.1.0/24. And inside the, and we will create a internet gateway for the BCN, and after that we will create a compute instance web 0 inside a public subnet, and we will install Apache over there, and we will access it from our browser. Okay, these are the resources I have used for this slides.